All right, for this first one, what are they asking us to try and find? First of all, volume, okay? What is the only equation that we have gone through where we have to figure out the volume? And keep going. Okay, let's get a little bit more precise here. We're going to take the integral of pi r squared, right? Okay, now we do have to figure out what our radius is, and we have to figure out what our restrictions are on this one, okay? First of all, do we know our restrictions for this? No. How do we find them? Yep, we set them equal to each other. And we solve for x, so we're going to move the x squared over, take the square root, so x equals plus or minus 1. So we have the integral from 1 to -1. Remember, the bigger number goes on top. Okay, if you put the smaller number on top, you just take the absolute value of it at the end. Okay, how do we get our radius here? Not quite. You're close. Yeah, we subtract these two. So that would be -x squared plus 1, technically minus 0, and then we square that. Okay, so then you can just throw it in your calculator, right? What do we get for an answer here? What'd you get, Eli? You don't remember? Well, you got a calculator. Let's figure it out, people. Let's go. I know, it's just terrible. 3.35, we're sure. Somebody else get the same answer. I'm just making sure. I haven't done it. That's what you got? Okay. Solveig says yes. All right. Now it does say volume here. So we should put a label on here. What are we putting on here? Units cubed. Yep. All right. Any questions there? All right. Go ahead and do the next one. A little bit different. What do we do next one? Gentlemen, get it figured out. Let's go. I believe it or not, Eli, I wasn't too concerned about you. I could tell you were kind of doing stuff. You should do that to check to see if there's anything within your restrictions this time. When you set them equal to each other, do you get any new points of that we have to deal with? Are you sure? Eli brings up a good point. What was that, Drew? -1. Now you do get a plus or minus 1, right? Okay, we already have the positive one. The -1 is outside the restrictions, so technically we don't care about it. Okay, so then this is just from 1 to 0 of pi times -x squared minus a -1, that whole thing squared. Dang it. What do we get for an answer this time? 1.68. Okay. I believe it or not, Eli, I'll trust you. Only because Dallas got something kind of sort of close. All right. Hey, any questions there? Now, when this doesn't say anything, this is using, where we cut it into circles, where some people will call it by cutting it into discs to find that volume. All right. For the next ones, we're going to use another method to be able to find this. And that other method is by what's called cylindrical shells. All right, we're still finding volume. And believe it or not, we're doing a lot of the same stuff here. But how we find the volume is going to be a touch different. Nothing. All right, let's do it, Doc. All right, so Matt, hold up your water bottle there. I think you can handle it. Well, you didn't use that arm very much yesterday, did you? Come on. Yeah, you did make one. That's true. All right, so if you take a look at Matt's water bottle there, all right, what we're going to do is we're going to try and find the volume of this. Now, what we could do is we could cut that into discs like we did on the last ones. But instead, what we're going to do, we are going to put a whole bunch of tiny little cylinders inside of that water bottle. And if we integrate the cylinder, the area of the cylinders, then we can find the actual volume of it. So what we have here is, say that we have that water bottle. All right, now normally, how do you find, do you remember how you find the volume of a cylinder? Right. Pi r squared times the height. All right, now, for that, what we're going to do is, instead of just, and because we don't have a straight cylinder here, if you look at our equations here, they're a little bit different. All right, so for this, we are going to draw a whole bunch of little cylinders in here, and we're going to find the volume of each one of those, and we would pack that entire thing really tight. So then we could add up all the volume of those tiny little cylinders, and that would give us the volume of the entire thing here. Okay? Yes, Drew? Did you find the
The area of the cylinder, is it like surface area or?
The volume, I meant, sorry. Okay, so any questions there? What's that? Because if you look at Matt's water bottle, it's a little slanted there, isn't it? Okay. Now, this is now if it were perfectly straight up down and down, Ethan, like if you're talking about mine here, if it was perfectly straight up and down, then absolutely you could do that. Okay. But when you have some kind of curve, and we definitely have curves up there, right? With the square root in there, that would cause problems with it. Okay. So what we're going to do for this is we are going to, let me check something really quick here. Make sure, get them both copied down right away. You got them both copied down?
Yeah.
Mr. Doctor, I can use the restroom.
Sure.
Kids, shut up. Whoa.
Hey, why are you mad? Where's he going? You lost?
Probably can't take. He's gotta go to
All right. So what we're going to do here is we are going to integrate to be able to find the volume of this. We are going to integrate 2 pi r h. Okay. 2 pi r h. Now, as we did before, this 2 and the pi, those are just constant, those are numbers. So if we wanted to, we could bring this 2 and the pi out in front here. So 2 pi times the integral of r times h. All right, now, how did we find our r before? Yeah, we subtracted these two. Okay, so that part stays the same. To find our r, we're going to take the first one minus the second one. All right, now, our h is constantly changing. All right, it all depends on how quickly or slowly this is increasing, the square root of x here. So because of that, our height is just whatever the variable is here. So that's going to be an h. Or I'm sorry, that's going to be an x. What's that? Okay, now from here, what are we going to integrate between? We only have one value. What do we have to do here? How do we do that? Yeah, set them equal to each other. So we're going to set these two equal to each other. And then we solve for x. So we subtract the 2 over. So we get square root of x equals 0. Square both sides. Looks like x equals 0. So there's our other restriction there. So we are going between 1 and 0 of all of that. Okay, now when you type this in your calculator, be careful with this. Make sure that you integrate the whole thing. So you might have to put an extra set of parentheses in there. There's no squares involved. So go ahead and get an answer for that. What do we get for an answer here? Huh? Believe it or not, I agree with Eli. Eli, good work.
Thanks.
How'd you do it, Eli?
I put the parentheses around that x for x plus 2 y.
This is
What? Yep, you can do that. But there's one extra step that I said that you need to do, which I would guess if you don't do that step, you get the answer that you got, boys.
Seems like there's more room for error in this one.
Do we have to have the 2 pi out? I thought these ones said we didn't. Isn't the pi said we didn't have the 2 pi out?
Oh, I see what it is. Well, I'm going to multiply by 2 pi.
Oh, Eli, what are you doing? I gave you I put all my confidence in you.
Wait, what did he?
I just forgot to multiply. I got 1.25.
Now you're way off.
Oh, and then I got multiplied by 2. 2.51.
Yeah,
2.51.
You're sure now?
All
right, I guess that's what we get for listening to Eli. Sorry, Eli, I tried. All right, so 2.51 units cubed, right? Okay, is that what you guys got? All right, there you go. So for this next one, we're going to do practically the same thing. Now, because of this, notice that for these, along with the ones that we did before, we are not saying that's an approximation, are we? Okay, this is how you can find the actual volume of any shape. Okay, so, and this would give you a very exact shape here, or a very exact volume. Okay, so once again, for this next one, we are going 2 pi times the integral of r times h. How do we find our r value? Subtract the two of them. So square root of x plus 1 minus, and then with this minus sign, technically this is x squared minus 1, right? So if you wanted to, like McKenna said for the last one, if you wanted to simplify these ones here, this gets down to the square root of x minus x squared for our radius. What is our height here? What's our height? X. Okay, and then we are just missing our restrictions here. Okay, now this might be a little bit more complicated having that square root in there along with a square. So we're going to set these equal to each other. All right, the ones are going to cancel here. So we've got square root of x equals x squared. How are you going to solve for this? There's two different ways. Okay, some of you are already grabbing the calculator and graphing it out. That's fine, you can do that. Okay, if you didn't want to, Matt, what did you say? I would square both sides, yeah. That gets rid of the square root. So x equals x to the fourth. Then what we're going to have to do is we're going to have to get both of them on the same side. So this is an x to the fourth minus x equals 0. Now what can we do? Okay, you could do that. You're not wrong. Okay. Okay, we could factor out an x, right? So this ends up being x times x cubed minus 1 equals 0. And then we're going to have to factor a difference of 2 cubes. Do you guys remember how to do that? And there you go. That's right, Drew. So we square the first term. Then we multiply these two together, except switch the sign. So this becomes a positive x. And then we square the last term. All right. Now, for this, from here, we set all of those equal to 0. We get x equals 0. We get x equals 1. Like Ethan said, you could have just plugged in a 1 and seen that that equals 0. All right. And then this one, this is going to give you imaginary numbers here. So we don't have to worry about those at all. Okay, so this is just from 1 to 0. All right, so type that in. Carl's going to get us an answer here. Yes, you are. Carl, we're waiting on you. If you have to do it manually, do it manually. Good luck.
0.94.
0.94. Really? You got it that fast? You want to go up to the board and show me how you did it?
No.
I think you do.
I can't do it. It can't be.
It's not 0.94. Nice try.
Nice try. Come on. What?
Are you sure it is?
Yeah.
Let's see what I get. Come on.
What?
You sure, Carl?
I got 0.94.
So in other words, Abby's sure, is what you're really saying.
Yes, I'm 100% sure. 0.94.
Yes. Yep, 0.94. All right, so make sure, couple things that we've already seen here. Make sure that you keep this 2 pi out in front, okay? Or just make sure that it's involved in there in some way in general, okay? And then make sure that you have this extra x on the end of it. All right, any questions so far? No, we're not done. It says page of 4 of 4 up there. All right, let's go. Take a look at this one. How is this one different? It's revolving around the x's instead of the y's, okay? So you do all of the same stuff here. Okay, so let's take a look at this first one. All right, we've got x equals pi squared, or y squared plus 2, and x equals 2, and then we know y equals 1. So there's one of our restrictions. We just got to figure out the other one. So we set those equal to each other. All right, and we end up with y equals 0 here. So our integral is going to be from 1 to 0. We can throw the 2 pi out in front. We just got to figure out what r and h are this time. What is r for this one? Yeah, if we simplify it, it just ends up being a y squared, right? Because when we subtract these, the 2's go away. So y squared, what is the h going to be here? Why is it a y? It was an x on the last one. Yeah, because that's what the variable is. It's just that easy, okay? So if you've got a y in your radius, you're going to put a y as your height.
Why is it 1, 0?
It's just how it worked this time. So it's not for the next one. All right, so give me an answer, please. Carl, you got an answer for me? Really? When you're putting it in your calculator, do you have to put a y in there? No, it's just a variable, right? So you can put any variable you want in there, just as long as it stays consistent throughout the problem. Carl, what do we get?
I got.
You got?
Hold on.
You got?
I'll do myself so I can thank you.
Or you could just copy Abby's, because chances are Abby's right.
1.57.
Abby was correct. There you go. All right. Any questions here? Go ahead and do the last one. And then we're good for today. I know, it's just so rough. Just a different equation based on what they're asking us here. It should get you the same answer, yes. unless they tell you, unless you're told to use a specific one. But you should get the same answer either way. Elliot, what's our equation going to be here?
The final there?
No, well, yeah, whatever you want to give me. Close.
You just silly, I was wide.
Those are Y's up there. But, okay. You were getting it ready for your calculator that can handle Y's in there?
Yeah, the one that
I gotcha. All right, so what do we get for an answer here? Carl, you got this one too?
Oh, I'm doing different.
Shocking.
I got 160.85.
160.85. That seems a little large there. You sure about that, Carl? You're 100% sure? You've got that much faith in the ability surrounding you, huh?
Yep.
All right.
Never wrong.
Abby is never wrong. All right, there you go. All right, ladies and gentlemen, any